When we are adding and subtracting rational expressions, we need to make sure that we have a common denominator. Number 9 is an example of two fractions that we're adding together. They do have a common denominator, so as you would recall, when you're adding and subtracting fractions and you have a common denominator, you retain that common denominator and you simply add or subtract, whatever the problem dictates, the numerators. So we're going to add the numerators, 3y plus x. So our answer is 3y plus x all over 5. Now the problem to number 10 also has a common denominator, but this time we're going to be subtracting the two fractions. So once again, we're going to retain the denominator of 3x plus 1, and this time we're going to subtract. We've got 7x, and we're going to subtract all of the numerator of the second fraction. So when we say all of, we need to make sure that we use those parentheses. We don't want to just subtract the x. We want to subtract the -2 or the -2 as well. And when we subtract a -2, that becomes positive. And I'll show you that right here. We keep the denominator of 3x plus 1, and then I have 7x minus x plus 2. And 7x minus x is 6x plus 2 over 3x plus 1. Now, 6x plus 2 is grouped and 3x plus 1 is grouped. I'm going to factor out a 2 out of the numerator, which gives me 3x plus 1 times 2 in the numerator, and then I have a 3x plus 1 in the denominator. The 3x plus 1 over 3x plus 1 is a factor or a quotient of 1. So my final answer is just 2. This next problem doesn't have a common denominator, so we need to get a common denominator. So my fraction, 8 over 5p, we need to fix it just a little bit. The second fraction has a 4 that the first fraction is going to need. So I'm going to multiply by 4 over 4, so that now the first fraction's denominator has exactly what the second fraction's denominator has, which is a 4p. Now, the second fraction is going to need that 5 in the denominator. So we can't just multiply or put a 5 there. We need to multiply by 5 over 5 so that we're multiplying by a factor of 1. Now my common denominator, I've got 32 over 20p plus 15 over 20p. That's going to become a 20p in the denominator, and 32 plus 15 is 47. 47 over 20 does not reduce, so that's our final answer. Number 12, we'll practice this again. This one's going to be subtraction. We're going to have to get that common denominator. So we've got 7 over 18a cubed b squared minus 2 over 9ab. Now this time the second fraction is going to need a 2 so that they both have a coefficient of 18. So we're going to multiply by 2 over 2. We also need an a squared to be multiplied to the second one, so that a times a squared becomes that a cubed. And we're going to need another b in our factor. So now we have 7 over 18a cubed b squared minus 4a squared b over 18a cubed b squared. we keep the denominator of 18 a cubed b squared, and all we have is 7 minus 4a squared b in the numerator, and I'm going to put that in parentheses. Now I'm putting it in parentheses because it is in the numerator, and before we can cancel things out, if we're adding and subtracting in the numerator, we have to do that before we can start dividing. So you have to calculate that numerator. Well, we don't know what 7 minus 4a squared b is, so I'm going to keep it in parentheses, grouped together, and that would be our final answer. Now in the next video, I'm going to do number 13, 14, and a few problems over here, 15 and 16. These are more common types of problems, 13 through 16, that you'll see in your homework and on a test.